The next trip to the moon just got the official thumbs up. The Artemis 1 mission will attempt its first launch next Monday, August 29th.
So it's an unmanned rocket. It will carry a new protective vest to determine whether people could spend more time in space. Now, NASA hopes to send the first woman and first person of color to the moon by 2025. Adam Frank is a professor of astrophysics at the University of Rochester and the author of Light of the Stars, Alien Worlds, and the Fate of the Earth. There's a lot in that book. Professor Frank, it's always good to see you. Your notes to our producers about this mission had 3 exclamation points. How excited are you?
As I said in those notes, finally, right? It's been almost 50 years since we had anybody get beyond low Earth orbit, which is basically like, you know, our porch, right? We haven't even been able to get anybody across the street space-wise. And so, you know, this mission is the beginning of really what will be the real leap, the giant leap for humanity, which is basically to get a base, a moon base, eventually, which, you know, your kids or grandkids can visit in, you know, a few decades.
But what does that mean, Professor? If we have a moon base where our grandkids are going, then what? Where are they going to from there?
Well, the whole solar system. I mean, what's remarkable is 50 years ago, we finally managed to make this step that people had dreamed about for like, you know, thousands of years. We got to the moon and then we're like, we don't want to do that anymore. When instead we should have, like, you know, put down some kind of permanent build a base that could be kind of almost like a gas station, if you think about it, or a way station to get to Mars, to get to Venus, to get to the outer, to get to Jupiter. And so really both the exploration of space and the commercial utilization of space really requires us having a permanent settlement that's outside of the deep gravity well of the Earth. So this is really the first step in getting that to go.
Speaking of Jupiter, the James Webb Telescope is really showing off. These new pictures of Jupiter, this is, I mean, beautiful oranges and yellows and blues and purples. What do you see here?
Yeah, I see. One of the first things I recognize is about 400 years ago, like the first time anybody'd seen Jupiter through a telescope was Galileo, and his telescope was about the size of a cucumber slice, you know, the width. And now we've got one that's in space and it's the size of a large truck. And so, you know, we're getting these views of our nearby, you know, gas giant planet that are just stunning. What I particularly like are the aurora. You can see at the top, at the North and South Pole, you can see this glow, which is the same kind of thing you can see if you ever see the Northern Lights. But in this case, it's Jupiter's magnetic field rather than the Earth's magnetic field doing it. And Jupiter's magnetic field is 20,000 times more powerful and reaches, you know, deep into space. So you're seeing like really powerful, really violent processes happening with a kind of detail as if you had like a super high resolution camera.
That's very cool. So that's something cool to look at. Now, help us understand this cool thing to listen to. This is the sound of a black hole. I mean, what do you hear there, Professor?
I hear the video, the space horror video game I played like a few years ago. It's pretty ominous, isn't it? It's a pretty amazing sound. What you're really hearing there is sound waves that are being driven into the gas surrounding the black hole due to extraordinary violent processes happening around the black hole. And what's really cool here is this is science allowing you to hear, which is something that would be inaudible to you, right? So what these are, you've got very hot gas around this galaxy, and then that hot gas emits X-rays, and those X-rays can get to us, and we can see with another great telescope, the Chandra X-ray telescope, and then you can decode that and hear the sound of this violent ringing of the gas as energy gets pumped into it from the black hole. So it's like with a microphone. When you're talking to a microphone, it turns your voice into electromagnetic waves, and then your radio turns it back into sound. But here you're hearing the voice of a supermassive black hole that's billions of times larger than the sun, or more massive than the sun.
It's all so mind-blowing. Professor Adam Frank, thank you very much for explaining it to us.
Thank you, Professor.
Oh, it's
New home sales